Hello, and welcome to Dystopian Electronics Workshop. Today, what we're going to do is actually repair some electronics that I have here in the workshop. So this is my DVD player. It's been in my workshop for quite a few years. I bought it new. But if you look right here, oh, wrong side. If you look right here, the power light is blinking red. And so I knew there was something wrong with it. And actually, you spin it around, here is the optical audio output. And you can see that that is blinking as well. What that tells me is that there is something wrong with the power supply on this. So we're going to crack it open, see if we can find anything messed up, and try to fix it. So as I'm taking this apart, I just had to point out here on the label, the date of manufacture for this was October 2005. So that's 17 years old. I suppose it's a pretty good amount of time for any electronics to last. But let's crack it open and look inside. And for your viewing pleasure, I actually removed all but one of these screws already. So I'll give you a quick tour around the DVD player here. Starting over here on the right, this is the actual optical drive that pops in and out. This is the brain of the unit. It's got all the control chips and everything. And over here on the left, this is actually where we're going to be looking. This is the circuit board. It has all of the AC to DC conversion, and it's usually where we're going to have a problem. So let me spin this around and zoom in. What we're going to look here, there's a bunch of electrolytic capacitors. We're looking for one that, instead of being perfectly smooth and flat, has a little bulge. This one right here has that. Let me see if I can zoom in on that. So we'll pull that out and get a better close-up of it. Throw it into our tester and see if that is in fact what's causing us our trouble. Good news is I got this on video, so I'll be able to figure out how to put it back together when I'm done. I am using one additional toy to make this a little easier today. Instead of just storing the screws in a pile on the desk and hoping I don't lose them, actually throwing them into this little magnetic tray. That lets me keep all the screws in the same place. Nice thing so far, all of these screws are the same size, same length, same pitch, so they should all be interchangeable. Ooh. Ooh. Oh, we got one more. All right, we got the circuit board free. What we're going to go ahead and do is pull out the soldering iron, desolder this bad capacitor, look and see if we can find any other bad capacitors. So we got this chucked up in the vise here. And if you look right here, this is the capacitor that we're going to remove. But for right now, I'm going to flip this over in the vise. So it's right here that we're going to pull this capacitor. Tighten down. Do this around. There's the first leg we need to pull. Second leg. So that came out nice and easy. You can see here, this is a 10 volt, 1000 microfarad. Got my handy dandy LCR meter. We are going to hook this in. There you go. No unknown or damaged part. That is definitely no good. I'm going to grab our part bin from Do 1. And in here, gone ahead and pulled out the 2 largest capacitors that we pulled off of that telephone. Unfortunately, neither one of them exactly match the specs of the damaged part. Option number 1, 100 microfarad, 16 volt. Test that. That's coming out at 106 microfarads. Here's option number 2, 470 microfarads at 6.3 volts. So we'll test that. Okay, that's 413. Given the choice, I think I'm going to go with the one that's closer, even though it's slightly lower voltage rating. So let's go ahead and pull back our circuit board, get it lined up, and try soldering this other component in where it belongs. I'm going to flip this around here for a second and show you. This is where that component came out of, and you'll see there's a section that has no cross hatches and one that has cross hatches. If we look up here at this other capacitor, you can see right where the stripe is in line with the cross hatches. So the cross hatch is where we're going to want our negative leg. I got the new capacitor in place. Need to flip it over and solder it. Just wanted to show you the alignment first. When you're dealing with capacitors, that is important. They are polarized. There's already solder on here. I'm just going to add a little bit more to make sure it gets on that leg. Partially because those are old components. The flux helps clean off the connection. Let's pop this back in and see if it works. Turn off the soldering iron. All right, we're just going to line this right back up where it was. Plastic standoff goes in. Want to make sure the repair actually corrected our problem. We don't need to go back and test more components. Right now, plug this in. Plug that in. Final thing is our AC. Bad news. We did not fix our problem. The question is it just because we used the wrong capacitor? Probably. I'll be right back. Okay, well, that's part of the fun of fixing things with scavenged components is it doesn't always work. Fortunately, I got another alternative for this project. This DVD player was not scavenged. It is not going to become part of the workshop other than it's my DVD player I use when I'm in the workshop. So what I do have here is I got 2 more bins of capacitors that I've scavenged over the history of my life. These don't count towards due necessarily, but I'm pretty sure if we dig through here, we'll find the exact component values we need. There you go, 1000 microfarad. That was just fortunate. The very first thing I picked up was 16 volt, 1000 microfarad. Doesn't matter if your voltage is higher, as long as that component value is the same, you're good to go. Lower voltage value like we used earlier is not ideal. So let's test this. Make sure it tests in the right range. Oop. $944.4. That's close enough. So let's pull that out, solder in this new piece. And if that doesn't work, we're gonna have to start testing all the other capacitors on the board until we find another one that's bad. All right, we got everything put back together. Let's see how we did. And I see a solid power light. There you go. So we saved this DVD player. When I was taking out that other capacitor, I did notice that the legs were just really short and probably weren't making a solid electrical connection. So I'm going to set that aside. We'll use it for a different project. It did test fine in the tester, but that's okay because this is back functioning and we'll be back in the shop. So let me throw the lid back on and then we can put it away. So here is that bad capacitor. I just wanted to see if I can get it so you could see the bulge there at the top. A lot of the time you'll see fluid actually leaking out of these. Sometimes if you look at the bottom, the legs will be popped out. This one's not so bad. I think I thought we'd do just for fun is crack this open and see what it looks like on the inside. I do not recommend you do this. On the outside here, first you just have plastic coating. This has all the labeling information and everything. The rest of it is just a metal can. Peel back this lip. This little bottom part here is actually just a rubber insulator. Should come out fairly easily. There you go. Inside that, there's coiled up, looks almost like paper. It has your dielectric that makes your capacitor. Since this one is shot, I've torn it apart already. Let's see how deep into it we can get. Okay, there's the inside of this capacitor. There it is coiled up. These have all kinds of nasty chemicals in them. You can see these legs are just sticking in. You can actually just pull it right out. And there you go. That is what the inside of a capacitor looks like. You know what? Let's go nuts. Slice this open so we can get a cross-sectional view. see, that's just layer after layer of material rolled on there, one long thin piece. And that's what's inside a capacitor. Well, that's all we have for this episode of Dystopian Electronics Workshop. Thanks for watching. I hope you enjoyed this video. And if you did, don't forget to like and subscribe and share it with your friends. Until next time, you get out there and do something.